so here we are now working on this particular example. So a lot of times we do talk about fish for some reason. Again, usually because it has a high mercury content, and that's kind of a concern. So here we go. I have a 780-gram sample of fish that contains the toxic limit for mercury, which is 0.001 parts per million. What mass of mercury is in the fish sample? Okay, well, here we go. What is the question giving me? Well, I have 780 grams of fish. So grams is a mass. In this particular case, I have a mass of fish that contains mercury. So this would have to be the solution. Keep in mind that a solution doesn't mean that it has to be like a liquid, right? So we're talking really, it could be anything from a gas to a solid, right? So we need to keep that in mind here. It contains a toxic limit for mercury at 0.001 parts per million. ppm, this is parts per million. Question is asking me what mass of mercury, so mass, in this case of the solute, is what the question is asking me for. So I'm going to go ahead and I'm going to put my formula down. So parts per million is equal to the mass of solute over the mass of solution times by 10 to the 6 parts per million. Okay, so I'm going to again set up this ratio. Why? Because I like it and I feel like it's the easiest way to do this. So it's going to be parts per million over 10 to the 6 is equal to the mass of solute over the mass of solution. I'm going to put in my values here. So I have 0.001 parts per million, and I have a mass of solution at 780 grams. Okay, so, and here, sorry, divided by 10 to the 6, and this is kind of what I don't know. So cross multiply and divide, again, starting across the equal sign. So I'm going to start here and cross multiply and divide. So what this is going to look like is 0.001 parts per million times 780 grams all over 10 to the 6. Oh, that looks like 106. Here we go. 10 to the 6 parts per million. Parts per million is going to cancel out. I'm going to get a value in grams, which makes sense because what I'm looking for is a mass. So here we go. Bracket 0.001. Okay, times the 780, end bracket divided by 10 to the power of 6. And I get an answer there, and it's already nicely put into scientific notation for me. So my answer being 7.8 times 10 to the negative 7. So that e negative 7 is really saying times 10 to the negative 7. Now I'm going to look and see how many significant figures I can have. So here I've got 3. And over here, remember that leading zeros don't count, so that's actually 1. So I have to report this to one significant figure. Because the 8 is greater than 5, I'm going to round up. Okay, so this is going to be 8 times 10 to the negative 7. Grams. Not parts per million, grams. All right, so there we go. There's the answer for that particular example. Thank you for watching the solution.